Hello friends, today the topic I am going to discuss in front of you is the dynamic memory allocation, which means allocating memory dynamically at runtime. That is, not at the compile time, just as in the memory allocation which is done in the case of arrays. We do the static memory allocation technique, we employ the static memory allocation technique, but in this concept, we are going to allocate memory dynamically as and when and how much the user requires is to be allocated. So, no less, no more, but the amount of memory which is required by the program at that particular point of time when it is going to be executed is to be determined at the runtime. So, this is the runtime memory allocation technique or the dynamic memory allocation technique which is done at the runtime. So, the topic, now I am going to write the heading of the topic, dynamic memory allocation. So, this is the topic, dynamic memory allocation. So, this can be employed by several functions which I am going to describe in my upcoming videos, but today we are going to use a library function which is called the malloc function. That is, the malloc function's activity is to just dynamically allocate memory. It is present in the library function alloc.h. There is yet another function called calloc, which is quite similar to the malloc. In terms of the general syntax, it is a bit different, but we are going to employ the malloc function in order to dynamically allocate memory in our program, in our illustrative program. So, with the help of an illustrative program, I am going to describe the concept. I am going to explain the concept of this dynamic memory allocation. So, it is a fairly simple program of just storing some values in some contiguous memory locations, just as we have done in the case of static memory allocation technique using arrays. And we will put some numbers in some contiguous memory locations and get them printed as an output to the program. So, that was done previously in our previous videos in the form of static memory allocation technique, but the same program is now going to be handled by the concept of memory locations, dynamic memory allocation using the help of pointers. So, let us get started with writing the code of the program, and then after that I am going to explain what is going underneath the programming concept. So, let me write the code. Hash include stdio.h, and then we have to include another library function which is called the alloc.h, and alloc.h is the library function which will hold the malloc function which is to be employed in the program in order to dynamically allocate memory. So, we are going to include another header file in this program which is called the alloc.h after the declaration of after the inclusion of the stdio.h header file. No, so I am just going to write this hash include alloc.h. So, this is another header file. Now, we come to the main portion, int main. We will take n to be supplied by the user in the form of number of elements to be given by the user, n, then a loop variable I, then obviously a pointer variable, star ptr. So, these are the three variables which are required for this program. So, now we will write printf how many elements, new line, user will give input %d ampersand n. So, this is the number of elements supplied by the user from the standard input device. Now, we are going to take the variables one by one into the dynamically allocated memory. So how can we just allocate the allocate the memory locations in contiguous positions by means of dynamic memory allocation? Now I am just going to show you the technique by this statement. What is the pointer variable we have taken? PTR, int star PTR. So PTR is equal to, it will return something which is to be returned in PTR is nothing but an address of an integer value. So address of an integer value is to be returned to this PTR by means of that malloc function. So we are going to write the malloc function. Please take a note of the syntax which we are going to use in the case of malloc function, is that we'll write in this manner: int star, data type will be int star malloc n is the number of variables the user will input from the keyboard during the runtime. User has given n, suppose the user has given 3, then only 3 positions will be allocated in the memory at the runtime. If the user gives 2, then 2 places will be allocated. If the user gives 100, then 100 will be allocated. So we are not going to define the dimension of the array as we have done in our previous videos when we use the static memory allocation technique. So we have not taken an array. See this program, it doesn't have a declaration of an array, of an integer array. We have only some variables, normal integer variables, along with the integer pointer variable which is called PTR. And in this way we are not going to waste any space. If we require, suppose we require, or we will just supply 5 elements and we have declared the array to be int x100 or int a100 like that. So 95 places of the array will be wasted, the memory will be wasted. So in that case, in order to prevent that wastage of memory space, we are going to employ this dynamic memory allocation technique. So in other words, in another terms, in another way, I can explain it to you in this terms that if the array was declared something like int a10 or int a100, and we are going to store about more than 100 elements, that is where we are going to store suppose 110 elements if we require, then in that case we will be suffering from a dearth of space, or a paucity of space will be there. So in order to cater for all the input elements which are given by the user, we will resort to this dynamic memory allocation technique. So this is a runtime memory allocation technique which takes care of both the situation, that is the dearth of space and the wastage of space. So it takes into account the memory of the computer system in order to get it run by the computer system. So this int star malloc, and n is the number given by the user from the keyboard as an input. N star means multiplied by, there is an operator which you all always are accustomed with this operator in different programs. You have seen this operator, size of returns the number of bytes of a particular data type or a particular variable. So n star size of int. So this is the entire syntax of this malloc function. So malloc is the library function contained in the alloc.h header file. It will return an integer pointer to be assigned to this PTR pointer variable. The syntax is like this: int star malloc parenthesis, opening parenthesis, n star size of operator, then comes bracket in the parenthesis, it comes the data type which we are using in this program. If we have used float or char or anything, any other data type, we would have written like that. We would have written float or char in the place of int. But since we are dealing with integer variables, we have given the specified the data type as int, and then the closing bracket, and then the closing bracket once again, and then the termination semicolon. So this is the dynamically allocated memory section. So it will just allocate as much memory as is required by the program in the runtime, as specified by the user in the form of the number of elements given by the variable specified by the variable n. So now we are going to input the values. We are going to take the elements one by one from the user and store it in the dynamically allocated memory. So for that, we'll write printf enter the elements, new line. Now for I is equal to 0, I less than n, I plus plus, this is quite familiar to you. Now we will take the help of pointer arithmetic in order to put the elements in the contiguous memory locations, and the memory allocation is, again I am reminding you, it has been done in a dynamic way. So in this case we will write what we will take scanf %d, we will not write ampersand, we will write what in terms of pointer arithmetic, ptr plus I. So scanf %d, ptr plus I. So this is the input part, and now we come to the output of the program, that is in which way we will get the output printed from this program. So after that we come to another loop construct, that is we will write a statement like this, a message, the elements entered are new line, then comes another for loop for I is equal to 0, I less than n, I plus plus, and then printf %d \t tab, and then we are going to print the contents of the memory locations. So contents of the memory locations is, you know that it is denoted by this way. In this way it is denoted star of ptr plus I. So ptr plus I is the memory location, and we are going to print star of ptr plus I, means the value at the address ptr plus I. So in this way we are going to print the entire array, entire set of elements which are given by the user from the keyboard, and after that we are only left with the statement of return 0. We will write over here return 0, and then we come to the closing brace of the int main section. So this is the program of dynamic memory allocation. This is a very simple illustrative program to show you the concept of dynamic memory allocation, in which we can store different elements in the form as we have done in the case of array in the way of static memory allocation, but here we have done it in the dynamic way. So if you have any doubts or queries pertaining to this program, you can well post your doubts or queries in the comment section below so that I can address them. Thanks for watching my video.